On today's edition of 285K shit no one cares about, we're going to talk about overclocking. It's backwards. It's wrong. Everything I know about overclocking is wrong this time. So I figured today I'm going to kind of take you guys along for the ride of some of the nuances that I'm figuring out with the 285K specifically. I don't even know if it's going to be worth it, to be honest, but there's some interesting things to talk about. So nonetheless, let's talk about it and show it. And who am I kidding? You don't care. Today's video is brought to you by the new, really super cool JSUSense Melty connector shirt, paying tribute to one of the best designs that's clearly ever existed. And if you don't like the vaporwave colors, we've got our OG gray and red colors available now. So get yours by following the link in the description below.
Nice.
Ow, I have a thigh cramp. So for this review, overclocking crap, I'm actually using the Falcon Northwest Talon, the same one I used in our initial review, because that's our comparison. I want to talk about this real quick. I mentioned how it was a $7,500 tower in there, and a lot of you guys lost your minds. Rightfully so, and Falcon even told me like, hey, this is a ridiculous, this is if a customer wanted to buy the system and they checked all the boxes. And every box you check reduces its, usually it's a diminished return on the kind of return that you get. So obviously you can spec these systems however you want. This is not sponsored by them or anything. I just want to point that out, that apparently some people are not right side or left side thinkers. They're zero side thinkers, and they just don't seem to know how this works. So the reason why it was so expensive is obviously it's got an RTX 4090 in there, which is very expensive. It just is. It's got a $1,000 motherboard in there. It's got the Asus Z890 Extreme, which is, we've talked about the Extremes in the past, and they're very, very, very expensive boards. It's got 3 Gen 5 2 terabyte NVMe drives in there that are in RAID 0. It's got 96 gigabytes of DDR5 6400 megatransfers RAM. It's not UDIM or CUDIM. I'm started messing with CUDIM. Actually, I take that back. I tried to boot our 8600 kit of Trident, whatever they're calling it this time, CUDIM RAM in here, and it would not. It would go to Windows and it would freeze and do all kinds of weird things. And that's one of the reasons why I didn't use CUDIM in our review, because of the fact that it's not ready yet. It's not stable yet. There's not even a QVL list yet for Z890. So it's gonna take some time, and I don't find it to be really all that interesting at the moment. Anyway, some of the nuances of Z890 though that I think they're important to talk about that I didn't mention in our review, and I probably should have, is the fact that you now have, this board has 6 M.2 drives on it, or not drives, but slots. And I think there's even another board that I think Gigabyte has it maybe, that has 7 M.2s, which is insane. That's just because of the PCH improvements, and as a platform, Arrow Lake is a much more forward, where you're getting much more Gen 5 support and all that sort of stuff. But not a whole lot of Gen 5 stuff out there yet, at least until the next graphics cards come out. So with that out of the way, let's kind of talk about overclocking here. So I should probably have started in the BIOS. I am going to do this in a couple of different ways here. I'm going to show you what BIOS settings I'm sort of messing with, but I'm going to do the bulk of the overclock testing using XTU, which is Intel's extreme tuning utility, or extreme frustration utility, depending on how you look at it. It's software. And as with any sort of overclocking through software, there can be bugs. There's pros, there's cons. I have a weird bug right now, you'll probably see it, where anytime I apply a setting, it wants to put my power limit at 1 watt. And I was trying to figure out why the hell the system became unresponsive, and that's because it went to 1 watt. And I don't know why it's doing that. So what I really need to do is wipe it and reinstall it. What I like to do is use XTU if I'm doing an Intel system, so I can kind of get the baseline figured out of where my overclocks are sort of stable. Then I can transfer those settings into BIOS, which is going to be probably a better option. Anyway, so this is the BIOS, as it probably looks very familiar to anyone with an Asus board, especially an ROG board. I am going to start by loading the profile that comes on the Falcon Northwest system. This is their rock solid profile. Every system they sell has a rock solid profile, and I think most SIs do, at least high-end SIs do. A lot of regular SIs don't do a profile, which they should. Gosh, there's so many weird things to talk about with overclocking on this one. So if I was to go in and remove all the defaults and load the Asus profiles, the system becomes very laggy and unresponsive, even if I don't push any sort of clocks. And I don't know why that is, to be honest. This is what I'm still trying to figure out. In fact, I've requested from Intel several times some sort of a white sheet or something mentioning some of the overclocking characteristics, so I kind of know where to start. I requested that more than a week ago. I still don't have it. This isn't the kind of thing that they really sort of support, to be honest, for the reviews. I requested it, so I can't really complain that it's taking time to get it, because again, it's not something that they really push or promote, is overclocking. Especially given on the heels of everything we've gone through with 13th and 14th gen, they probably don't want us going and messing with a lot of this stuff. But at the same time, they were like, you should overclock it. It's really neat. And it's like, cool, support that. Chirp, chirp, cricket, cricket, waiting, waiting. Anyway, moving on. So you can see here, Intel default settings, performance. So I'm gonna go ahead and move this to extreme. I could go ASUS Advanced OC Profile. What that essentially does is then ASUS kind of removes all the Intel logic when it comes to velocity boost, it changes the voltages, it changes the load line calibration, all of that stuff. And it basically just moves it way up high. And I did get it to actually run with the same settings without getting any additional score. My temps jumped from like mid 70s to low 90s by just enabling the ASUS profile. So all of the like temperature benefits we saw were gone, and I wasn't seeing any sort of benefit to score. And I think that's just because ASUS was once again pile driving voltage down the CPU's throat. And let's try to go ahead and avoid that for reasons that don't need to be described or explained unless you just crawled out of a rock for the first time in a year. I'm actually gonna be running the 6,000 megahertz, not 6,400, because if I'm gonna get this working right now, I do wanna run through my games again at the same way we tested it. And 6,000 megahertz is where I tested it, because that's where I also tested AMD, so I need that, apples to apples comparison there. Okay, so multi-core enhancement, auto let BIOS optimize, that's fine. I could also do enabled remove all limits. What that's gonna basically do, if I do remove all limits, on my next page here, when I go down to CPU power management. So you can see right now, the settings are kind of default. So maximum temperature, 115 C, sure, why not? All I'm doing here is removing any sort of thermal throttling, although we will not get anywhere near that. We might see 88 to 90 C with some of these settings. Unlimited ICC max, enabled. This is kind of an important one right here. One of the things I'm noticing is even though I'm pushing not the voltage, I'm not even touching voltage. I mean, I can, only a little bit, because of the fact that we're under the Intel Extreme profile, so it's still very strict with the voltage limits, for a good reason. Even though I'm gonna lift the amps and everything to max, I still will get current limit, EDC limit. So, which is interesting to me because I know we're not actually hitting the amp limits. So I'm not entirely sure why it's doing that, but it is. Power window. Another funny thing here is you can go to 128 second power time window, but if you go into XTU, it goes 256. So XTU has a different setting than the BIOS, which is interesting. So I don't know what power limit 4 switch is, to be honest. The tooltip says enable and disable power limit 4 function. Nice tool tips, ASUS. Glad to see nothing's changed. Moving on, 4,095 watts, 4,095 watts. I am removing the limits. Now, power core density throttle. This is a new setting, newish setting that I've only started playing with right now. It says this option allows users to disable P-core power density throttling for overclocking purpose. Once disabled, it cannot enable it in the same reset cycle. A warm or cold reset is required. So what it's saying is if you turn that on right now, you have to power cycle the system to make that setting change. I am going to go ahead and disable it. The reason being is I do believe this could be potentially related to the power limit throttle reason yes in XTU that I'm seeing, even though as you can see, I am lifting the limits very, very high. So I'm still trying to figure that one out, but I think I've kind of got a grasp of what's happening here enough to be able to kind of show you guys some of the performance uplift you can see when you deal with trying to overclock Core Ultra. Now, this is the Core Ultra 9, obviously the 285K. Your mileage is gonna your mileage is gonna vary depending on your silicon quality. There's always this assumption that Intel sends everyone like cherry-picked golden samples. Not true. Not true. In fact, almost every retail sample I've ever bought has been better than an Intel sample I've been provided. So let's just go ahead and throw that out the window right there. And I can tell you about the fact that I've been spending the last day sort of pulling my hair out, trying to figure out what the heck is happening when I'll see like a major uplift by changing one setting and then change one setting, like one small knob click, having it then drop like 1,000 points, trying to figure out what the heck is happening. So these are default settings right here. Performance core ratio, and this is the compact mode. Performance core ratio is at 54x multiplier. That is for the all core. It goes up to 5.7 for 1 and 2 core. and then 4.6 gigahertz E-core, and it will go up to 4.8, I believe. If I go to advanced view, it'll tell me. I believe it'll go up to 4.8. Yeah, no, 4.9. It'll go up to 4.9, up to 5. 1 to 5 of them will go up to 4.9. 6 to 8 will go to 4.7. 9 to 16 will go to 4.6. So a lot of what I'm gonna do right now will be in the advanced menu, but I wanna see if my bug persists. Do you see right here how Turbo Boost Power Max is at unlimited? That's the setting that keeps changing itself to 1 watt. This is also what I was talking about right here, how 128 seconds is the max in the BIOS, but I can switch that to 256 here. And I'm gonna hit apply. Let's see if that goes back to 1 watt. Sometimes it does, sometimes it doesn't. Yep, there it goes, 1 watt. I didn't touch that slider. So why did it go from unlimited down to 1 watt? That's the thing that's kind of driving me nuts right there. And I think it might have something to do with the fact that this 256 does not exist in the BIOS, but it exists in the software. Ow. So you don't know how much headache this was causing me because I didn't catch it at first. And I'm like, why? Because I thought what was happening here is it was somehow becoming unstable because the system becomes pretty much unresponsive because look, we are power limit throttle, yes, 100% of the time right now. That was absolutely driving me insane. And I don't know why it does that. Let's do Cinebench R23. I like to use R23 because it's a heat pumper. And that's what I'm checking for here is just high core count, workload, high heat to see how well our system will survive. So all stock settings, I didn't change anything right now except I lifted the power limits. This is not actually how I do my test. Our test was with normal limits, so it was like a 42,002 something, I think, 1 something, somewhere around there on our chart. I don't recall off the top of my head. And our score right here was a 42,742. So it's about 500 points higher than our initial benchmark runs that you guys saw in our benchmark video. So what I'm gonna do right now is I'm gonna go ahead and I'm just going to demonstrate to you what happens if we start pushing performance core. So I'm gonna do a multiplier of 1. Now if you just do in the compact view, if you do the right arrow, it goes up 1 whole multiplier. But in the advanced view, because of the fact that it's now a bit, it's only 0.16, I think you can change it now. So if I hit the little right, actually if I drop down, you can see I'm 0.17. So you see you get like 7.17 multiplier ratios now, which is new. Because Intel up until recently was always 100. 100 is all you got. Actually, AMD for the longest time would give you down to 1. So I just want to point that out now. I'm just doing full X multipliers here. I'm not playing with the 0.17 yet. So I am going to now go back to compact view. I put it at 55. I've applied it. And I just want to see what's happening right here. So you can see right now it's running at 5.5. I do have the performance profile in Windows enabled. We went from a 42,742 by just pushing 100 megahertz to our P cores. So we actually went down from a 42,597. So I'm gonna run it again just to see there is run variance. There's always gonna be run variance. Any little background task could affect the score overall. In fact, having XTU open can actually affect the score. So there's a 42,506, it actually dropped a little bit again. And this is why I say overclocking is backwards right now. Because I'm finding the more I push the P core, the less performance I get. Even if we're not throttling. Even if we're not temperature bound, even if we're not power bound, which we're not right now, 42,458. And every run after that will actually be a little less than the run before it. And this is not because of heat soak or anything like that. This is just a weird nuance with Core 9 or Core Ultra, whatever the f they're calling it this time around. Now here's the thing, thermal velocity boost is still active. So what could be potentially happening here is there could be some clock variance that's happening, but it's happening so fast we're not seeing it in the reporting. So that could actually be something that's happening. But let's see what happens right now if we were to just increase the cache ratio. So we're gonna go up from 3.8 to 4 gigahertz on the cache. This one setting could actually potentially uplift gaming performance if the tile design and the interconnect is causing a latency issue like AMD was dealing with back when Ryzen was new until they got the fabric sort of figured out and sped up. That wasn't a fart, I swear, it was the chair, I was leaning forward. To a 42,829. So you can see we got a bigger boost so far by just pushing the cache 200 megahertz than we have by even touching the P cores. Now we're only about 100 above that first run, but the first run always tends to be the best because it's the coolest. Then you do get a little bit of heat, so it's like an engine. Every time you run a car on a dyno, if you're pushing high horsepower, if you run them back to back to back to back, you're gonna see horsepower drops because of heat soak. And that does exist inside the die itself too. I'm not talking about the cooler's capability of cooling it. I mean just all the SMCs, all the resistors and everything, they get hot. And then that can start to affect performance a little bit. Nope, 42,687. So we actually dropped a little bit. And that's something I started noticing as well, is the farther I pushed the cache, the more diminished returns we had. Actually, we didn't have diminished returns, we just had diminished result, which is beyond diminished returns. That's actually a negative return. So let's test that right now at 40 again. There's our 42,871. So you see how we started to like crest the top of the bell, if you will, and start working our way down. So now I have cache at 40. I'm gonna leave it there. I probably could push it farther if I wanted to play with the voltage and all that, but I'm not going to. This time around, the CPU seems intelligent where if I tell it to go to a certain frequency and it detects that like voltage is not quite there to provide the stability it needs, it doesn't actually go to the target all the way. It's kind of like the GPUs are when it comes to like GPU boost. Yes, I know that's how the TVB works, or thermal velocity boost, but even when I would disable it, I would notice it still did that. So I've done a lot of my testing off camera with thermal velocity boost off entirely and was not seeing a tangible benefit to turning it off. So right now I'm leaving it on. I can actually turn it off real time right here. Now you can see TVB temp 1 is at 75C, temp 2 is at 100C. But check this out. You can see the 8 active cores right now do have a 1x offset for, well, I'm gonna turn that off because I wanna keep that all as locked down as possible. So by just turning off that offset now, let's see what happens to our score. 43,106. And I wanna talk about something that happened here, because what happens with thermal velocity boost offset is it basically says if 7 active cores, or in this case, 8 active cores, reach 75C or above, drop the multiplier by 1. That's what the offset is. The offset's a negative offset. It's saying reduce it by 1. We actually have it set at 100C. It's set to 0 because at 100C it would automatically thermal throttle anyway. Technically 105 is the new max, but out of the box 100 is actually what we were seeing on the motherboards. So we're already seeing some variance between what Intel is telling the motherboard manufacturers and what the motherboards are actually doing. So this is kind of the opposite problem where Intel is saying, hey, you could go hotter, and the motherboards are like, no, we're gonna stay at 100. So I wanna point that out. 105 is the new max, but 100 is where this board was set to until I went in and made it 115, as you guys saw. But our temperature did actually hit 90C in the package on that run because of the fact that it's no longer saying reduce the clock speeds a little bit. But by having everything set at 0, thermal velocity boost at this point is not doing anything. Even if I turn it off, it's the same right now because there's no table for it to follow. And the only table that's active on the CPU out of the box is 8 active cores on the P core and a 1x offset. That's all there is. Okay, now let's do this first. Let's push the 8 active core overclock to 5.5 and let's see what happens here. So from a 43,064, and we need to keep an eye on the temps now because now the temps are gonna start moving their way up. There's 87, 89. Now we're EDC throttle limit. Ignore the package TDP reporting, it's wrong in here. It's absolutely wrong. But our EDP limit throttle is yes. And that was a 42,728. So this is where having the Intel Extreme Profile active, even though I have lifted those numbers to unlimited, it's still limited. So this is probably, to be honest, DLVR doing its job, if you wanna know the truth. That's probably what this is. The thing is, I can't see exactly what that limit is. Now, if I back this back to 5.4, we may not even see that limit pop back up. And then what we'll see is a score potentially come back. See, 100 megahertz across those 8 cores. So what's probably happening here, obviously the package as a whole is drawing too much power. And I think what's happening is we're hitting a limit, truly a voltage limit. And that just says current, and current is a formulation of watts and amps and volts, right? So, or watts and or volts, amps, there's an equation there depending on which way you go with the equation there. So back up to a 43,055. I think what's happening there is by pushing the P cores farther, they demand so much voltage and so much power based on the limit that Intel has in place with DLVR that is why we're not able to go any farther with the P core. So I'm gonna drop this back down to 5.3. But what I'm gonna do now, raise our all E core to 5 gigahertz, from 4.6 to 5 gigahertz. See our E-core frequency is at 4.9, not quite there because of the same reason we talked about. We are limited as expected. But our score jumps up to a 44,298. So we gained 1,100 points by just pushing the E-core. Now, if I want to give even more availability to our E-cores, we have to drop the P-core. And the crazy part about that is I found that by dropping the P-core and raising the E-core was giving me more overall performance. The E-cores are definitely carrying a heavy load. So I'm going to drop down to 5.2 on the P-core. And I'm going to go to 5.1 on the E-core. That might get us effectively 5.0 on the E-core under load. Nope, still 4.97. So we're still going to be hitting, but look, we're not hitting that EDP limit. So I'm not able to figure out why I'm not getting the full frequency I'm asking for. That's one of the weird nuances I'm dealing with. It could be fixed in a featured BIOS. I don't know, it could be a reporting thing from XTU. So there's a 44,093, didn't really gain anything. For the record, the best score I've been able to get off camera so far was 45,008, and I have not been able to recreate it. So, as you can see, for all-core overclocking, it's interesting, to say the least. I mean, obviously with the extreme profile, there are limits in place that are stopping me from being able to really go any farther. To be honest, cooling is going to stop me from being able to go much farther either. So what I'm going to do right now is I'm going to show you with the ASUS overclock profile, just out of the box, what that does to our temps. All right, so ASUS Advanced OC profile. It's warning me you're probably gonna break your stuff. That's fine. I'm okay with that. I do this so you don't have to. All limits are removed. Let me just reboot that so it can reset its power settings. There it is, so unlimited, unlimited. Everything I've already done. There's the 128, it only goes to 128. So here's the other thing I noticed. So by going to Intel Extreme Profile, I talked about I didn't know what current power limit 4 was. If you may not have noticed, I didn't call it out. It said 450 watt under the Intel profile. Under the Asus profile, it says 0 watts. So I'm still not exactly sure what that is doing, to be honest. 0 might be unlimited. So I think 90C was the hottest we saw with the Intel profile while with me overclocking it. 75 to 78C package reported temp is what we saw with the Intel Extreme profile and no overclocking. Exactly as we were before, as you can see, efficiency core is still at 46x, performance ratio core is at 54x. Okay, it's actually looking all right there. 76C, that's pretty normal. 5.3, 5.3 and 4.6, exactly as we're expecting. Okay, 42.244, that actually matches like our initial benchmark scores. So I'm gonna push 5.5 all core, so there's 77, 78. So once again, I have P core set to 5.6, but it's only going 5.5. Our temp is now 87. So that extra 100 megahertz jumped us, what, 8C instantly? We won't gain any score really. 42,577 to a 42,774. So far each P core jump has been worth 200 points at the most. So I'm gonna drop back down to 5.4. I'm gonna go to 5.0 on the E core. So 83C on the package. We are getting 5 gigahertz on our E core, which is kind of nice. That's a 44,496. So you see by me pushing the E cores and then using the Asus profile to limit or to get rid of the limits that were kind of hitting me, I saw an incredible jump in performance right there. Now I do need to get rid of this 1x multiplier because that's one of the reasons why we weren't getting the full 5.5 I was setting a moment ago. And let's go ahead now and see if 5.1 will run. I have gotten 5.2 to go by dropping P core down to 5.3. So let's see, here's 5.1 gigahertz all core E core. Temps are probably gonna scream right now. 92 and a blue screen. So with tuning, which will take a lot longer than you're getting with this video, I have a feeling I could get 5.2 all core to run with 5.3 P core all core with cache at 4. I don't know yet how worth it that's gonna be because I have not found the fully stable settings to be able to run to redo my benchmarks. So I think we'll revisit this as soon as I get a little bit more familiar with some of the knobs and dials that are existing with this one, but it's crazy. See, E-core overclocking on 12th gen, 13th gen, and 14th gen always yielded us pretty good results, but not this kind of result. See, what I would typically be able to do with the E-core, P-core layout on previous gens was push the P-cores, which was giving me very exponential, like big increases in performance at the cost of power and temperature, but as long as I could keep the temperatures in check, it would go. Then push the E-cores to the stable limit or the thermal limit. And then they would take the score and push it up a little bit. Now it's the P-cores pushing up the E-cores to carry the score, which is crazy because you saw we got nearly 2,000 points by just touching E-core. That is insane. So I really want to rerun this with our games to see if pushing E-core up will help our games a lot. I'm really wondering if that's going to be the case. All right, there you go. So that's our first look at overclocking. It's going to take some time for me to figure this out. Hopefully I get that sheet from Intel to sort of understand what's different this time. The tile designs make things interesting. It was Ryzen overclocking is still, it's still very, very different than what most people would expect with overclocking. The days of just having one core, 2 threads, and that times how many cores, and then just pushing voltage to the core and it's done is just, it's so much more complicated now. With the IMC being on the chip, we obviously got XE graphics on the chip. Obviously we've got our tile design with our E-cores and our P-cores, and the E-cores are spread out across the tile, or the P-cores are spread out around the tile with the E-cores in between them. That's why the numbering is so weird in a hardware monitor. So anyway, there we go. It's been a long enough video. You guys asked for an overclocking guide. Don't call this a guide as much as it's a, here's what's happening when I push this button type of vlog. A full guide, like once I figure out like enough to be able to guide people, I can do that guide. I just don't think it's gonna be worth it, if you wanna know the truth. If you have to do this to get any better gaming performance, just get a different CPU, honestly. We already know the Core Ultra series is not good at games. It's just not. So overclocking should not be the fix for that. All right, guys, thanks for watching. We'll see you in the next one.